Now, in this session, we will find the inverse Z transform by partial fraction expansion method. We will see some examples. Say, we have to find the Z transform, inverse Z transform of 1 plus Z to the power minus 1 upon 1 minus Z to the power minus 1 plus 0.5 Z to the power minus 2. Okay. And given ROC is Z is greater than some radius R. Okay. That is signal is causal. Okay. Now, first we multiply and divide this x of z, numerator and denominator, by z square. The result we obtain is z square plus z upon z square minus z plus 0.5. Okay. Now, x of z divided by z is obtained from this equation 1 is z plus 1 upon z square minus z plus 0.5. Okay. This is equation number 2. We factorize this equation number 2. We get 2 poles z minus p1 and z minus p2. Okay, the p1 value obtained is 1 by 2 plus j by 2 and p2 is 1 by 2 minus j by 2. Here p1 and p2 is not equal, but p2 is equal to p1 complex conjugate. This relation is there. Okay, this is equation number 3. Now we, by partial fraction expansion method, we expand this function x of z by z is equal to a1 upon z minus p1 plus a2 upon z minus p2. Okay. In order to find the value of a1, we multiply x of z by z minus p1 and set z value equals to p1. Okay, so we will get result as z plus p1 upon z minus p2 and setting z equals to p1. So p1 plus 1 upon p1 plus minus p2. Okay, substituting p1 and p2 value, we get half plus j by 2 plus 1 divided by 1 by 2 plus j by 2 minus 1 by 2 plus j by 2. Result we obtained is a1 is equal to half minus 3 by 2 j. Okay. Similarly, to find the value of a2, we multiply z minus p2 with x of z upon z and set the value of z equal to p2. So we get z plus 1 upon z minus p1 here. Okay. Now setting value of z equals to p2, so we get result p2 plus 1 upon p2 minus p1. Okay. Now substituting p2 and p1 value, we get half minus j by 2 plus 1 upon 1 by 2 minus j by 2 minus half minus j by 2. Result we obtained a2 by solving this equal to half plus j 3 by 2. As we see a1 and a2 is complex conjugate of a1. So we can conclude that if p2 is complex conjugate of p1, then the coefficient of a1, a2 we get follows this relation. a2 is also a complex conjugate of a1. Okay. Now we substitute this a1, a2 value in equation 4. Okay. The equation 4 again I am rewriting here. X of z upon z equals to a1 z minus p1 plus a2 upon z minus p2. Okay. For simplicity, I am just keeping here a1 and p1 only, not writing this half plus j3 by 2. Okay. So here we rearrange this equation number. I am giving this equation number 5 and z is taking this side. So then we get a1 is equal to z upon z minus p1 plus, as we know, a2 is a complex conjugate of a1. So here I am writing a1 complex conjugate into z upon z minus, as we know, this p2 is a complex conjugate of p1. So here I am writing instead of p2 I am writing p1 complex conjugate value. Okay. Now this equation number 6, I am again writing this arranging this term and writing this equation 6 in terms of z to the power minus 1. Okay, 1 minus z to the power minus 1 p1. Okay, plus a1 complex conjugate 1 minus p1 complex conjugate z to the power minus 1. Okay, as for causal signal, we know inverse z transform of this is follows this as a1 to the power n a1 into p1 to the power n u of n plus a1 complex conjugate value into p1 complex conjugate value to the power n u of n. Okay, this is the result of this a1 p1 complex conjugate plus a1 complex conjugate plus into p1 complex to the power n u of n. This is the final result. Again, as this is the complex values, if we write uh, this two complex conjugate poles, we can write it as a combine and can be formed as a real signal component. For that, we'll express this a1 and p1 in polar form. So a1 is equal to a1, its magnitude and its phase alpha. Okay, and p1 is p1 value into p1 into e to the power j beta 1. Okay, so equation, this result xn, this result equation 8, we can write it as a x n equals to a1 and p1 to the power n and e to the power j beta 1 n plus alpha 1. Okay, plus e to the power minus j beta 1 n plus alpha 1. Okay, u of n. This we can convert it into cos signal. X of n equals to 2 a1 p1 to the power n cos beta 1 n plus alpha 1 u of n. This is also the result, inverse Z transform of x of z. Okay, for ROC, z is greater than p1. Okay, say its value is equal to rk. Here only one complex conjugate value is, so we are using rk is equal to 1. Okay, depending on the value of rk, the distance of rk of the pole from the origin determines the exponential weighting, that is either it is growing or decaying or constant value. As each pair of complex conjugate poles in the Z domain results in a causal sinusoidal signal component with an exponential envelope. So if Rk, here in generalized form I am writing, means K is number of multiple poles, complex poles. Okay, Rk is greater than 1, then signal is growing, exponentially growing signal. Means like this. Okay, if Rk is less than 1, then signal is decaying, and if Rk is equals to 1, then it is constant, amplitude constant. It means this angle of the poles with the positive real axis provides the frequency of the sinusoidal signal, and the zero equivalently, that is the numerator of the rational transform, affects only indirectly the amplitude and phase of x of n through this ak value, this value a. Okay, and for if here we have considered only single pole, a complex pole. If multiple poles are there, either real or complex, the inverse Z transform is p to the power z minus 1 minus p to the power z minus 1 whole square is equal to n p to the power n u of n. Okay, provided ROC is Z greater than p. Okay, now let's take next example. When x of z, second example, x of z is equal to 1 upon 1 plus z to the power minus 1 into 1 minus z to the power minus 1 whole square. Okay, here we are taking the example of multiple poles. Okay, first we rearrange this. So divide this by z cube and multiply this x of z with z to the power 3. So the result we get is z plus 1, z cube upon z plus 1 into z minus 1 whole square. Okay. Now x of z upon z equals to z square upon z plus 1 into z minus 1 whole square. Now taking partial fraction expansion, we set this equation 1. We can write this as x of z upon z equals to a1 upon z plus 1 plus a2 upon z minus 1 plus a3 upon z minus 1 whole square. Okay. Now to find the value of a1, multiply x of z upon z by z plus 1. So the result we get remaining is z square upon z minus 1 whole square, and set z equals to 1 minus 1. Okay. So we get the result 1 by 4. Again, to find the value of a2, first we differentiate this z minus 1 whole square x of z by z. Okay, and then set its value z equals to 1. So differentiate z square upon z plus 1 and substitute its value z equals to 1. How we will differentiate? For this, suppose this is numerator, this is denominator, and we have to differentiate this. So take this as a constant denominator and differentiate first with numerator, then minus, then take numerator as a constant and differentiate with denominator divided by square of this denominator. Okay. So we get the result of this differentiation as 2z plus 1 into z minus z square into 1 divided by z plus 1 whole square, and setting z value equals to 1. Okay, so we get result 2 into 2 minus 1 divided by 2 square equals to 3 by 4. Okay, a2 value obtained is 3 by 4, a1 value obtained is 1 by 4. Now to get a3 value, a3 equals to, we multiply z minus 1 to the whole square with the x of z upon z, and setting z equals to 1, we get z square upon z plus 1, setting z equals to 1, results 1 by 2. Okay, so we substitute this a1, a2, a3 value in equation 2. Okay, so we get x of z equals to 1 by 4 upon z plus 1 plus 3 by 4 z upon z minus 1 plus 1 by 2 z upon 1 by 2 here z I'm taking here only, 1 by 2 z upon z minus 1 whole square. Okay, now writing this equation number 3 in terms of z inverse negative power, we get 1 by 4 upon 1 plus z inverse plus 3 by 4 z 1 minus z inverse plus this, that cancel out, plus 1 by 2 upon 1 minus z inverse whole square. Okay. Now taking inverse z transform by considering its ROC. Okay. If say ROC, so that is it is a causal signal. Z is greater than 1. Okay. So first term expression 1 by 4 1 by 4 upon 1 plus z to the power minus 1 will become 1 by 4 minus 1 to the power n u of n. Okay. And since it is plus sign, so minus 1 to the power n it is coming. Second term, that is 3 by 4 upon 1 minus z to the power minus 1, its z transform is equal to 3 by 4 u of n. Okay. We write this z transform. And the third term 1 by 2 1 minus z to the power minus 1 whole square, its z transform is half of n u of n. So x of n is summation of these three. X of n is equal to 1 by 4 minus 1 to the power n u of n plus 3 by 4 u of n plus 1 by 2 n u of n. Okay. Now let's take another example. That is find the inverse z transform of x of z given as z to the power 3 minus 10 z to the power 2 minus 4z plus 4 upon 2z square minus 2z minus 4 with ROC given here as z is less than 1, that is causal signal. Here we one thing we note that numerator degree, highest degree of z is 3 and denominator highest degree is 2. So we can conclude that m is greater than n. And whenever m is greater than or equal to n, that is number of zeros are greater than or equal to number of poles, the function is improper rational function. So before doing inverse z transform, we have to convert this into proper rational function and sum of its polynomials. Okay, this improper rational function into proper rational function, we must convert this. So to convert this, we use long division method. Right, this z to the power 3 minus 10 z to the power 2 minus 4z plus 4 is divided by 2z square minus 2z minus 4. In order to cancel z to the power 3, multiply this denominator by 0.5z. So we get the result z to the power 3 minus z to the power 2 minus 2 minus z. Okay, change the sign, we get the result minus z square minus 2z minus plus 4. Okay, now we have to cancel this minus z square, so we have to multiply by denominator by 4.5. Okay, so we get the result minus z square plus 9z plus 18, and change the sign, we get the result minus 11z minus 14. We can write this result as x of z is equal to 0.5z minus 4.5 minus this 11z plus 14. Minus sign we have taken out, and denominator divide by this denominator 2z square minus 2z minus 4. Say equation number 5. Next we rearrange this equation number 5. X of z is equal to 0.5z minus 4.5 minus this denominator 2 is taken as common, so this denominator will become z square minus z minus 2, and divide this 2 by numerator, so numerator will become 5.5z plus 7. Okay, this is equation number 6. Now this is a proper rational function. So let's say x1z, this xz equal to 0.5z minus 4.5 minus x1z. Now we will doing partial fraction method x1z here. By comparing equation 6 and equation 7, we come to know that x1z is here is 5.5z plus 7 upon z square minus z minus 2. Okay. Now we will factorize the denominator of x1z, 5.5z plus 7 upon 7. When we factorize this, we get z plus 1 and into z minus 2. Okay. Now doing partial fraction of this x1z, a1 upon z plus 1 plus a2 upon z minus 2. Okay. To find a1, multiply z plus 1 with x1z and set z equals to minus 1. We will get the result. So 5.5z plus 7 upon z minus 2 remains, as z plus 1 gets cancelled out, and setting z equals to minus 1. So we get result as 0.5. Okay. 7 minus 5.5 upon minus 3 is equal to, we get minus 0.5. Okay. Next a2, in order to get a2, we will again multiply z minus 2 with x1z and set z equals to 2. We get 5.5 z plus 7 upon z plus 1. So we get here 5.5 into 2 plus 7 upon 3. The result we get is 6. Okay. So x1, x2, z, here we can write it as a minus 0.5 upon z plus 1 and plus 6 upon z minus 2. This we can substitute in equation 7. So equation 7 we write again here, x of z is equal to 0.5 z minus 4.5 minus, now this equation number 7, equation number 8, minus minus sign will get positive 0.5 z plus 1, and this minus sign will become minus 6 upon z minus 2. This is equation 9. Again rearranging this equation in terms of z positive and z to the power minus negative term. So 0.5 multiplied by this numerator by z inverse, this denominator will become 1 plus z inverse. Okay. Similarly, in this multiplied numerator by z inverse, we get denominator 1 minus 2 z to the power minus 1. Okay. This is equation number 10. Now we take inverse z transform of equation number 10. The first term is 0.5 z. We know that the inverse z transform is this is 0.5 del to the power del of n plus 1, as using time shifting property. Okay. The next term 4.5. If we take z transform of this, we get 4.5 del of n. And this is first term. This is second term. And for third term, that is 0.5 z to the power minus 1 upon 1 plus z to the power minus 1. Okay, z transform हमें देखना है. So what will it be? We know that z transform of 0.5 z to the not including the z, 1 plus z to the power minus 1 is (0.5 minus 1 to the power n u of minus n minus 1, as ROC given is less than 1. Okay. So this is a non-causal signal. And if we consider this z inverse also, then using time shifting property, this we substitute n equals to n minus 1. Okay. So this 0.5 z to the power minus 1 upon 1 plus z to the power minus 1 will result as minus 0.5, this is minus 0.5, minus 1 to the power, and we substitute n minus 1 here, minus 9 n minus 1, u of, only here will remain minus n. Why? Minus n is minus n minus 1, minus 1. This will result minus n. Okay. So the inverse z transform of 0.5 z to the minus 1 upon 1 plus z to the minus 1 is minus 0.5 into minus 1 to the power n minus 1 into u of minus n. Next, fourth term, that is this 6 z inverse upon 1 minus 2 z inverse. Okay, we have to find out. Again, first we find without z inverse 1 minus 2 z to the power minus 1, as this is a non-positive sequence since ROC is less than 1. So we can write it as a 6 into 2 to the power n minus sign u of minus n minus 1. This is the result. Now using time shifter property, we can find out this also. So we have to just put n equals to n minus 1 in this expression. So we will get the result minus 6 2 to the power n. Instead of n, we have to replace by n minus 1. Okay, so u of minus n will remain. Why? Same by this. Okay, so this is the fourth term, inverse Z transform. So x of n, we can write it as inverse Z transform of first term. We get is 0.5 del of n, 0.5 del of n plus 1. Then what is next? Minus 4 point del of n. Then third term is this, and here positive sign is there. Okay, so we will write here minus 0.5 minus 1 to the power n minus 1 u of minus n. Okay, and for the fourth term, here we can see it is minus sign. Okay, and fourth term we have received here also minus sign. So minus sign will become positive sign. So plus 6 2 to the power n minus 1 u of minus n. Okay, this is the result. So we have taken also example of improper function. In here we find just do first improper function into sum of its polynomial and proper rational function. We've just converted improper rational function into sum of its polynomials and proper rational function. Then we take the proper rational function inverse Z transform by using partial fraction method. Okay, thank you.